Namaskar. Fundamentals of Physics video lecture series. This is my fourth lecture and part 3 of Kinematics in one dimension. In this lecture, we will discuss time and mass as base quantities. The length as base quantities was defined and introduced in the previous talk. I begin with my presentation with 3 quotations. Albert Einstein has said, "The only reason for time is so that everything doesn't happen at once." C.S. Lewis has said, "For the present is the point at which time touches eternity." And quoting Thales, "Time is the wisest of all things that are, for it brings everything to light." Whether philosophy or science, one of the most difficult concepts is the concept of time. It has been changing and evolving, and in fact, there was a time when there was no time, and then the Big Bang occurred. The universe was created, and so was created space and time. These are advanced concepts which we will be learning in later stage of this video lecture series. To continue the presentation from where we left in last lecture. In last lecture, I have talked about International System of Quantities, ISQ, which defines base quantities and derived quantities. 7 base quantities have been chosen and then internationally accepted by the community of scientists, the SI unit system, which we will be using in our lectures and learning process. SI prefix makes it convenient to express the numerical value in easily understandable form. The length as a dimension, as a base quantity, and the unit of length and the numerical range in which we have answers when we make measurements of length or quantities having dimensions of length. That was also pointed out in the last lecture. And in the end, we have discussed scientific notation, because scientific notation will be useful in expressing the numerical values of the physical quantities. The time, and if I ask you a question, what is time? Maybe you can answer very easily, and you can tell me the local time at your place. But time is a concept, a notion, which may be known to, in some manner, to all biological species which have any level of intelligence. Because with any level of intelligence, the biological species may also get a perception through their biological clock about time and about happening and about the events. The layman's notion of time is like that of indefinite continued progress of existence and events. And so time becomes for an individual meaningful when his birth takes place, and maybe in day-to-day life it loses its meaning when death occurs for him. So we have layman's notion of the past, of the present, and the future. And in the philosophy of Buddha, the importance of the present, the now, has been emphasized. I would like to point out that artifacts from the Paleolithic suggest that the moon was used to reckon time as early as 6,000 years ago. So it's not a new concept or notion which is known to humanity for long. But what is scientific meaning of time and whether we have a final answer or not, that we will be able to understand much better even after conclusion of the series. In this series of lectures, initially we make a particular concept, and that will be based on certain mathematical understanding of the concept of time, and we will start using it without bothering about the philosophical questions. But it has been very important right from the beginning. The measurement of time, it is said, begin with the invention of what we call sundials. One of the sundial is shown, which is in Russia located in the picture above me. The measurement of time begin with the invention of sundial in ancient Egypt sometime prior to 1500 BC, and the day was divided in that period of time into 12 hours, but these 12 hours were not of same duration. These 12 hours were of variable durations, and they were also varying with the season. So it was quite complicated conceptualization of time using sundials, which was used even in before Common Era period, 1500 before Common Era. So that is very interesting story to understand. And of course, time as a measurable concept effectively ceased during those days in the hours of darkness, because if there is no sundial, and sundial will not be able to communicate. There is sundial, but the sundial will not be able to communicate about the notion of time or measurement of time. So that was an interesting beginning. Then came the water clock, the sunglasses, which were based on the measurement of time based on the flow of some substance, water or sand. These water clock and sun clocks were largely used for measuring the time duration rather than keeping the time record. And the time duration of some activity such as a speech, a lecture, cooking time, length of a consultation, etc. So time and time duration both are important. An event has a beginning at a particular instant of time, but it may have a duration of time as we understand it from layman's perspective. But the new concept of hour which is there is due to the due to invention of the clock in the 13th century Europe, and hour was chosen as a basic unit of time, and that was chosen in honor of the goddess of season, Hore. The goddess of seasons keeps on changing, and so the early realization of the importance of understanding time was in terms of cyclic time or the change of season, and the goddesses of season, Hore, were chosen, and the present term which we use in the clock is hour. And hour we will define physically or scientifically also, but the ability to measure time came much later than the invention of the clock in 13th century, and the modern understanding came maybe 300 years later, the first understanding of or first making of the clock in 13th century. At the same time, just for sake of knowing, I am telling you about the mythopoeic views of time. As I have earlier pointed out, that we all have some kind of understanding of time in respect of what we call our past, our present and our future. what we aim at. So we believe and we have this sense of perception of time that the events happen in progression. Time is constantly moving or is changing, and it is beyond the human control. So it is something which is like divine. That is a common or layman's view. And so in mythopic views, several aspects of time have been described and emphasized. The cyclic time, that change of season, after every year we find maybe the stars at same positions, and so by observing the world around us we could notice the cyclic time much earlier in human history. And then to celebrate those cyclic time and those things which we liked in the happening, we have developed several rituals. So there is a ritualistic meaning, and all the festivals come and are repeated after every year, and that is also based on the cyclic concept of time. If you have watched the serial Mahabharat, then in Mahabharat time has been personified and it starts with Main Samay Hu. So time has been personified by many writers, and there are many poetic descriptions of time available in ancient literature, and those all aspects are very interesting to develop an understanding. And finally, for few, the time is good or time is bad, and we have our emotions attached with time, and as emotions are fluctuating, we have a kind of feeling of the presence of time in through our emotions. And a few may associate the time with astrology and may believe, which is not scientific, but may believe that the changes which are happening are because of those combinations. Scientifically, it is an absurd thing to say, and it can be easily established scientifically that it is not scientific. But with the civilization, progress in civilization, the calendars and several calendars, And what is a calendar? In a calendar, you have to define the beginning of time, and then the dates are assigned. Months, dates, and years are assigned. So we know about several calendars, and here I am displaying one of the interesting thing which you can work out for yourself also. My date of birth is June 14th, 1960 in Gregorian calendar, and since I was born before sunrise, but as per Gregorian calendar it was a Tuesday. So my date of birth in Gregorian calendar is June 14, 1960, Tuesday. But in Julian calendar it is June 1, 1960. It is different in different calendars. So later we will introduce the concept of t equal to 0, the origin of time. So every calendar has a particular origin of time, and the use of these calendars have been very difficult because they have different type and durations. Roman calendar, Hebrew calendar, Persian calendar, Israel calendar, Mayan long calendar, in all those calendars my date of birth has been displayed here, just to emphasize that the date of the birth depends upon the choice of the calendar. And I have also given the date of birth in Indian calendars, Vikram Samvat, and there are two forms, Purnimanta and Amanta, and based on those two forms I have given my date of birth, and I have tried to express it in numbers also, and the date of birth is corresponding to the Gregorian calendar 14 June 1960 I have given here. But you will find that the day is also different, because in Indian calendars it is assumed that the next Monday or Tuesday will begin. So Tuesday will begin only after sunrise, And since I was born just before sunrise, few minutes before sunrise, so in Gregorian calendar, my day of birth is Tuesday, but in Indian calendar, my day of birth is Monday. So it's very interesting thing that the old concept of time or even calendar is not an easy concept to understand unless you pay attentions to it and the finer aspects. It may become an easier when you ignore many things. So as I have said, every layman, everybody understand and have a kind of understanding of the time and the importance of the time. But what we are interested in here is the concept of time as it appears in the physics course. But here, before defining the time in as based on our requirement of physics, I would also like to give you information about the human perception of time. So that is based on our brain, functioning of the brain, and here I am quoting David M. Eagleman. Because different types of sensory information, hearing, seeing, touch and so on, are processed at different speeds by different neural architecture in our brain. So your brain faces an enormous challenge. It's not easy for brain. And what is the best story that can be constructed about the outside world? So the brain constructed story may also not be a very true story, because we get information through perception and these different perceptions are processed at different speeds by the brain. So when you understand neuroscience and neural activity, you will be better able to appreciate these things. And that's why he has said the days of thinking of time as a river, evenly flowing, always advancing, are over. That is the layman's perception. Time perception, just like vision, is a construction of the brain and is shockingly easy to manipulate experimentally. So optical illusions can be created now by using technology experimentally. We all know about optical illusions, in which things appear different from how they really are. So similarly, the illusion of time. Less well known is the word of temporal illusions, the time illusions. When you begin to look for temporal illusions, they appear everywhere. In the movie theater, even in this presentation, you perceive a series of static images as a smoothly flowing scene. Or perhaps you have noticed when glancing at a clock that the second hand sometimes appears to take longer than the normal to move to its next position, as though the clocks were momentarily frozen. These are associated with optical illusion, and our human perception of time is a creation of our brain and is based on that. But for understanding of physics, we need to define it in a mathematical quantity and in much precise manner, and we will be changing the concept of time. Concept of time is not same in all theoretical frameworks of physics. So right now the concept of time which I am introducing is the concept of space and time in Galilean theory of relativity. In Galilean theory of relativity, the concept of time involves the definitions of the past, present and future, and the present is defined in this term that we can choose any instant as a present instant and call it t equal to 0. Then if we assign a real number to the time, then negative real numbers will indicate the events in past in comparison to t equal to 0 being present, and positive values of t will indicate the events in future, and there is no limit, and so we can go to infinite past and maybe infinite future in the Galilean view of or conceptualization of time. The Galilean view which has developed the view has been developed in the period when the pendulum clock was designed by Christian Huygens in 1665, and the clocks were available. And with these clocks, we have been able to improve our understanding of the concept of time and the concept of time interval also. So for now, for our practical purpose to understand my lectures and this video lecture series, you have to first assume that just like length, time is a dimension, and just like length, time is also a base quantity, and therefore length and time will be identical in that manner that both are dimensions but both are independent dimensions. So in Galilean theory of relativity, length cannot be converted into time and time cannot be transformed into length, and so on. It may not be true in advanced theories. So in our scientific understanding of time, because we are choosing time as a base quantity, we need to define the unit of time. And as you know that in the previous talk, I have talked about several unit systems, CGS, FPS, MKS or SI unit system. In all those unit systems, we find that the unit of time is same, and that is second. And how we arrive at second? So when Egyptian used the concept of division of a day into 12 hours, the concept was based on the fact maybe that in a year there are, on an average one can say, 12 lunar cycles, so 12 lunar months, so in a year. So the factor of 12 was chosen, it is believed. Now we have also accepted it scientifically, but the Egyptian hour was of different duration. We have fixed definition for scientific measurement. So one day will corresponds to what we call one mean solar day. One mean solar day, if you divide it into 86,400 seconds, if you take 86,400th part of it, then that will may be defined as second. So in other words, the standard of time second here is being defined in terms of the day, and the day has been defined in the basis of the rotation of Earth on its axis, and which causes day and night, but the day keeps on changing. So when we say one day, we means one mean solar day. So all 365 days of a year, and if a mean is taken, that will define mean solar day. So we call one mean solar day, and if we take 86,400th part of that, that will be called 1 second. But we will continue to use the other units of time, like say 1 minute consists of 60 seconds and a day consists of 24 into 60 seconds. So a day consists of 24 hours, so 24 into 60 seconds, and an hour consists of 60 minutes, so 3600 seconds. So with this one can define a second, and that is the definition of the second, which was chosen in the beginning for scientific study and for scientific measurements. Of the many repetitive phenomena in the earth, the rotation of the earth was chosen as a basis, you can say. And one mean solar second was defined to be, as I have pointed out, 86,400th part of a mean solar day. And mean solar day is the measure of time representing the interval between consecutive passes of the sun across the meridian averaged over 1 year. So the meridian was specifically chosen for it, and till now we have been using it as one of the important reference for assigning time. Then the clocks were invented, and any phenomenon, because one can say that change occurs with time, or change has no meaning if there is no time, or time has no meaning if there is no change. So any change which take place repeatedly can be used as a measurement of time, and that has been on that basis we have developed different type of clocks, whether oscillating pendulum clock or mass spring clock or a quartz clock, all works on the same basic principle that a phenomenon which repeats itself, so which is cyclic, can be chosen for measurement of time. Interestingly, initially it used to be believed that time is created by the clock, and that's why the phrase of the clock appeared, and the phase of the clock is generally referred as o'clock. So when you say 7 o'clock, it is 7 of the clock, and meaning like that. Then we could make quartz clock, and the first quartz clock was built in 1927. These quartz crystals, which are piezoelectric crystals, have important behavior, and that can be used, and they can be used to make periodic vibrations by supplying electricity, or they can be electrically sustained periodic vibration. So a design is required definitely, and if the crystal is accurately shaped and positioned, it will oscillate at a desired frequency. Most of the quartz clocks which are in use are so designed that the frequency is 32,768 Hz, and based on that we can now define the time. So time second, because 1 second, so because the frequency is given, and frequency means how many times the oscillations will be repeated in 1 second. So that is 32,768 cyclic vibration will take place in 1 second for the crystal quartz clock. Later on, we could further improve and get a new standard for the time based on this cesium clock. Cesium, and we will later understand the atomic spectra and the splitting in the atomic spectra. The cesium has one electron in its outermost orbital 6s, and this one electron, the lone electron of 6s, undergoes splitting of energy levels, and the energy levels are split because of its interaction with the nuclear spin, and that's very important. But due to this splitting of energy levels of between the interactions, due to the interaction with the nuclear spin, the two energy levels differ by a certain amount, which can be converted into frequency. So you know energy equals to h nu, the formula which was given by Planck, and on that basis we can convert it into nu, the frequency. The splitting of energy is very small energy. In fact, it is too small in comparison to even ionization energy of cesium. And ionization of energy of cesium is, you can say, 1 lakh times more than the splitting energy. But we have now the technology and the precision which we can achieve of measurement of time is precision of 1 second in 1.4 billion years, and even it is said that we can improve the clock to such a level, and I have read a paper where the precision can be of 1 second in 14-15 billion years. So the universe was created 13.7 billion years ago, so more than that. So very precise clocks, because all the other clocks like quartz clock, because shape, and if there is any deformity, then may lead to wrong calculation, so wrong results may be given. So we find that the cesium clocks are used in the current definition of the standard of time, and this frequency we have chosen as delta nu Cs. Here delta V is displayed, but it should be delta nu, and delta nu Cs, the hyperfine transition frequency of Cs, to be 919263170. Very big number, but since we have now the precision which is much better than that, therefore one can say that the new second which is defined on the basis of the hyperfine transition frequency of cesium delta nu Cs, and delta nu Cs can be experimentally measured, and by experimentally measuring it one can arrive at the values of this. These experimental measurements are carried out by using what we call atomic clocks. And now once we have defined the 1 second, as I have pointed out in my last lecture, that by using the speed of light one can define 1 meter. So in terms of delta nu Cs, the hyperpoint transition frequency and the speed of constant, the new definition of the meter or the current definition of meter is shown in the slide. It is 1 meter equal to 9192631770 divided by 299792458 times C divided by delta nu C S. So that is the definition of meter. But the standard of time, because of its being very important, I have captured an image from UTC yesterday, and that is shown here in the picture. The coordinated universal time. So that is nowadays being used even for our day-to-day life and recording and other purpose, and UTC is therefore very, very important. And you can search for the current UTC time, and if you know how to calculate from the current UTC time to your local time or Indian Standard Time, then that exercise is very simple mathematical exercise, and you can know the precise value of the local standard time at that particular moment. The cesium clocks are housed in satellites, and they make the basis for what we call global positioning system. But global positioning system, the framework will fail if we had no understanding of general theory of relativity. It involves the corrections which are required on the basis of general theory of relativity. So even the global positioning system is an indication that the Newtonian mechanics which we are going to develop, and if the universe is Newtonian and if the world is Newtonian, then maybe the global positioning system will not work in the manner it works now, and it's very useful to us. So it requires knowledge of general theory of relativity. A cesium atomic clock is also located at the National Physical Laboratory in New Delhi and maintains the Indian Standard of Time. Another fundamental concept of time is the Planck time. Just like the Planck length, Planck time and Planck mass, all the three are interrelated. But the Planck time cannot be used as a standard of time because it's very, very small value of time. And the Planck time is 5.391 into 10 raised to power minus 44 seconds. So now we have the precisions of measurement in the value of time, but nowhere close to this small number. And the Planck times let you know that the universe was created in the Big Bang as per Big Bang theory of cosmology. So if the creation takes place at t equals to 0, the cosmic time equal to 0, then from that cosmic time equal to 0 to the first 5.391 into 10 to the power minus 44 second, you can't know anything. It is restricted by the laws of nature. So what happened during the first duration of Planck time can never be known, and we can also never know what happens in a time interval much smaller than the Planck time. But this is not part of Newtonian mechanics. In Newtonian mechanics, any duration as small as 0 makes a meaning. In modern physics, as time duration which is smaller than Planck's time has no meaning or scientifically incorrect, because the laws of nature as established and agreeing with the experiments clearly give indication that the physics happening in a time interval smaller than this cannot be observed by us. So the Big Bang occurred, and since the Big Bang, we also define a time which is called cosmic time starting from the Big Bang, and Big Bang occurred 13.7 or 13.9 billion years ago, and there is a error involved in the cosmological measurements, so one cannot be very sure of the number, and it keeps on changing with our better understanding. So 13.7 billion years ago the Big Bang happened, and since then everything is changing, and maybe in future also everything will be changing. So the concept of time is very important, because there was a time when there was no time before Big Bang, then there was a time when there was no earth, no sun, then 6 billion years ago sun was created, earth was created 4.5 billion years ago, and we also came into existence, one can say, in form of a cell, biological cell, in 3.8 billion years ago. And in 3.8 billion years ago, maybe the RNA also came into existence much earlier than the cell. And so whether the COVID virus or the human being, if traced back biologically, then they have a history of 3.8 billion years. And definitely there was a period, long period of, one can say, half a billion year on Earth when life was not possible. There was no oxygen also initially on primordial Earth, and how oxygen came into existence. All those are interesting topics which we will come to in our discussion. We will take those things in our later lectures, much later lectures. And then we came into existence, and we, as far as biological species are concerned, are very new biological species, and we came into existence, and since then we have been exploring what is happening in the world, not from our origin time, but from the time when the Big Bang occurred. So the time durations which are of importance, so a range of duration, time duration of events I have given here, which gives you another picture that like length, this prefix nano, micro, iota will be very useful, will be very useful in understanding the time durations, because time durations are changing. So half-life of hydrogen is different than half-life of helium, and half-life of helium-10 is much smaller, and so on. So we understand the neutron is also not stable, and maybe among the listed time here, that is having the highest value of time duration, 885.7 seconds, is the mean lifetime of a free neutron, not a neutron which you generally conceptualize sometimes as existing in the nucleus. A wrong conceptualization, but that is common, and therefore a free neutron will not be able to live and will decay into proton, and the mean lifetime of the free neutron is of the order of, you can say, 900 seconds, or 900 seconds means 15 minutes. Next quantity which I wish to introduce for our development of one-dimensional motion of a particle, kinematics and then dynamics. This will become more important in the dynamics, and once we have defined the kinematics, we need to understand why the change in the state of motion occurs. And the Newton has given a framework which we know as Newtonian mechanics. And in Newtonian mechanics, the particle which has been conceptualized is having an intrinsic property called mass. This property is the measure of inertia, and the inertia is conceptualized in the Newton's first law of motion. And the second law of motion for particle F equal to ma provides both the definition of force as well as definition of m. Because the third quantity, acceleration, we will be defining kinematically very shortly in next lecture. So kinematical quantities Accelerations are easier to define. This is one equation which is given to you, and in this one equation, two concepts mathematically defined: the concept of force and the concept of mass, F equals to ma. So mass, and as a physical quantity, is an intrinsic property for a particle, and we believe that if there is a body which is made of particle, then this mass of the body is equal to the sum of the mass of all constituent particles. That kind of conceptualization we will be working on in our coming lectures. So remember, for a particle, the mass is constant because a particle is indivisible and mass is intrinsic property of the particle. So whatever mass it has, it will have the same value of mass throughout the course of motion or existence. But in case of a body is made of particles. Mass of the body is not constant. It may change in certain cases, and especially when it ejects out particles. And therefore, we will later come to know and study the propulsion of rocket. And there, because of the ejection, the mass of the system will be changing, and the equation F equals to ma. In fact, for a body, we will have to give a better definition, which we will discuss very shortly. So SI unit of mass again we need because it's a property, so it should be measured. The SI unit is kilogram and not gram. However, SI prefix kilo is being used. So SI prefix in case of mass are often used with gram, but as far as consideration is concerned, we consider 1 kilogram or kilogram as the SI unit of the base quantity mass, and the mass of 1 kg was initially defined in the same manner, like we had the definition of meter based on two fine engraved lines on a platinum iridium bar. That is a particular object which is kept in that particular object which is kept at the Bureau of Weights and Measures, and which is supposed to have the mass of 1 kg. And then the copies, by making and using the balance, the copies of the standard 1 kg mass can be made and are available in the laboratories worldwide and in India in NPL, and then we can use that to calibrate, and also we have techniques to calibrate the fractions of masses also. But when we consider this unit kilogram, it is not suitable for understanding the masses of atom, masses of elementary particles and things like that. For understanding the masses of atoms, another physical quantity unit was defined and was practically accepted in SI for expressing those things, and that was based on that the one atomic mass unit is equal to the mass of carbon 12 atom, where the masses of electron also is included. So mass of carbon 12 atom, I am not saying mass of carbon 12 nuclei, mass of carbon 12 atom divided by 12, and carbon 12 is a very stable isotope, so it is better to define it in terms of carbon 12. So one atomic unit in comparison to the SI unit kilogram turns out to be 1.661 into 10 raised to power minus 27 kg. So this conversion factor we can make use of. And if the value of mass when you measure becomes much smaller, then you can express it in terms of atomic unit rather than kilogram to facilitate that the number will be easier and to understand. So range of mass is given here. Mass of electron, which can be measured at, say, that can be also converted into the units of energy by using Einstein mass energy conversion relationship, E equals to mc square. So I have quoted and given both the values, and in this particular table we have the range of the values of mass. So maybe we also have in our understanding the notions of elementary particles in quantum field theory which have no mass at all, like photon and maybe neutrino also do not have mass, but it is widely believed that neutrinos may be having some mass. And we will come to that topic when we can take up standard model of high energy physics. So the electron is the lightest particle listed here, and the mass is 9.1 into 10 to the power minus 31 kg. And the biggest system, physical system, which includes all physical system of our universe, is the what is called the universe, and the mass of the universe is also given in the table, and mass of water molecules is in between at number 8 I have displaced. And you may be having a concern about your own mass also, and generally we call it weight, but it is expressed in terms of mass, and weight we will later understand that is a kind of gravitational pull exerted by the earth on human being, and so kg weight may be considered as a unit of force. So if you have mass of 60 kg, the force exerted by earth on you will be 60 kg weight, and your mass is 60 kg. So with that we have an understanding of the range of mass. Now to define and arrive at the new definition of the base quantity mass, the SI unit, kilogram, as I have said in my previous talk, that SI unit system, we have now adopted the definition of all physical quantities based on fundamental constants. So like the time, the definition of 1 second was based on hyperpoint splitting frequencies of cesium. For length, the meter was defined in terms of using that definition of time as well as using the particular value, specific value of the speed of light in vacuum. So 1 meter was defined in terms of speed of light and the hyperpoint splitting frequency of cesium. Now the Planck constant is used to arrive at the value of mass or 1 kilogram of mass. The Planck constant is not having dimension of mass. It is just like that the speed of light is not having dimension of length. The frequency is having a dimension, you can say, because it's an inverse dimension of time. But Planck's constant is having a dimension which is the dimension of, you can say, action, and that unit which we will assign to Planck constant is joule second, and so it has a particular dimension ml to t minus 1. So 1 dimension of mass, 2 of length, and an inverse dimension of time. So I will explain the dimension later on also in next lecture, or maybe next to next lecture, in coming lectures. But Planck constant, we use this particular value h equals to 6.62607015 into 10 raised to the power minus 34 joule second to define the 1 kilogram. Now the joule second is involving m in it because joule second has dimension of m L to t minus 1, as we say. So this is used in defining the 1 kg, and the definition of 1 kg therefore will involve, because the dimensions of the Planck constant involve L and T as well as M, so you will have to involve in the definition, along with the Planck constant, the speed of light and the hyperpoint splitting frequency of cesium. So 1 kg is defined in terms of the Planck constant, the speed of light and the hyperpoint splitting frequency in this manner, which is being displayed, which I would not like to read. You can make a note of it. And so by using the value of the Planck constant, which we can measure experimentally. So what this definition tells you, that if you have to determine 1 kg, use this definition, but determining 1 kg will require 3 measurements: measurement of C, measurement of H and measurement of delta nu Cs, the hyperfine splitting frequency of cesium. All these three measurements will be required to give a definition or meaning to 1 kg. So this is an interesting definition. An equivalent redefinition has also been given, and in this redefinitions we say that the kilogram is the mass of a body at rest whose equivalent energy equals the energy of a collection of photons whose frequencies sum to this huge number 1.35639248965 into 10 raised to power 50 hertz. And since we have known that energy E, you know already maybe from general knowledge that the energy can be expressed as h nu, and it can also be expressed in terms of mc square for a quanta, and so E equals to h nu as well as E equals to mc square. So every photon, which is a massless particle in fact, but is having, in modern understanding, but which is having energy, and so it has energy, and that energy can be converted into frequency. So, and once you have energy, you can convert it into mass. So the modern conceptualization, modern concepts have been used in this equivalent redefinition. However, the standard definitions of the meter, the kilogram and second are involved. This was just for your information that it takes, and it is an important issue, and it's an important topic in physics to understand the importance of how base quantities, the base units are defined. But when we will be making practical use of them, once we have accepted that the definition of the SI unit of the length is meter and that of the time is second and that of mass is kg, the calculations numerical by using the formulas of physics which we will obtain through derivation after development of theoretical framework, it would not be very difficult. So this complexity is associated with the defining these things, and the complexities associated with the measurements of quantity in very precise manners will not come across in our theoretical study. And if you just remember even that the SI unit for length, mass and time, whatever they are respectively, then that will help you in understanding coming lectures. But it is very important to understand and note that how we have arrived at the concepts of length, concept of mass and concept of the time in this particular manner, and how the standards have been chosen. Because if you understand those things very well, then you will be able to put what I will be discussing in coming lectures in correct and proper perspective. So with this, I would like to end my lecture with a quotation. It is from John Wheeler, and he said, "A black hole has no hair." And a black hole has no hair. Why he said so? Because summarizing the simplicity of black hole. Black hole is also a physical system, and this physical system, black hole, possesses only three intrinsic characteristics, mass being one of them. Mass, charge and spin, these are the three characteristics. And the John Wheeler is pointing out that black hole is like if you have a gathering of full of bald-pated people who had one characteristics in common of being bald maybe, but no difference. For bald people it makes no sense, no difference in hair length, style or color of individual hairs and so on. So color variation, individual variations, color variations, style variations and length variation of hairs have no meaning in a gathering of bald-pated people. So similarly is the presence of black hole in our universe. In our next talk, I will be now, because I have defined length, mass and time in some manner, so we will be now developing a theoretical structure, conceptual structure plus mathematical structure, so that we can describe the motion of particle in one-dimensional space and one-dimensional time. So it would be made clear what we mean by one-dimensional space and one-dimensional time. and you cannot combine the two and call two-dimensional, because as I have pointed out in these lectures that time and length are considered as base units which are not dependent on each other, mutually exclusive. So space, we will definitely generalize from one-dimensional space to two-dimensional space to three-dimensional space, which is more important, three-dimensional space, because we see objects in three dimensions. But time we will keep always in one dimension. But that doesn't mean time must have one dimension really. There are theories in physics which have been proposed which involve more than one dimensions of time. These theories have not been experimentally established, so I cannot comment about the importance of these theories at present. But when we make a theory, we start with assumptions and we have a freedom to build the theory in the manner we like. And if it agrees with the experiment, as pointed out in my first lecture, we feel happy about the theory, but that's a tentative case and we have to move. So with this, I conclude my fourth lecture in this video lecture series. If you like these lectures, then please click the like button. Please click subscribe to subscribe the channel, and you can click the bell icon to get notifications whenever the new lectures are uploaded. It is going to be a very long series and I hope you are enjoying it. All the best to you. Thank you for being with me.